And my my shirt is so wrinkled. My fucking face is wrinkled, that's for sure.
All right, welcome to the build. So it's moving quickly.
And their product velocity is intense.
We're both pretty involved in the Langchain community.
This is going to be an industry, like the whole thing is going to explode.
The hype cycle, it's like just because you hear everybody start talking about these things doesn't necessarily mean it's the right.
Need to go back, find out more because it's really interesting.
We're both obsessed with AI and their entire stack is just pivoted to agents.
The next question that usually comes after that is like, well, I'm fine-tuning an open model.
That's the biggest thing with the latest specs.
An exploding distribution vector.
I'm really excited. I think everybody is. I'm not the only one.
The build.
All right, welcome to the build. My name is Tom Spencer, and with me is Cameron, as always, looking very dapper with some very, very nice hair, I have to say, very nice.
And I ironed my shirt right before this.
How you been?
Good, man.
Where have you been, my long-lost friend?
Been head down working on things. Yeah.
All right, yeah, we're going to wait for that to drop at some point. We'll wait for it. Don't worry. We'll wait for it. What's new with me? Building agents, some agent stuff I want to take you through. I'm back in California, which is nice after all my travels.
I was a little bit surprised that you came to the table with some Microsoft, not only Microsoft, but medical stuff. So it's like a double whammy, and I'm excited.
A double whammy of unexpected. Yeah. So what I want to take you through is this Microsoft medical kind of agent diagnosis paper that you may have seen doing the rounds, and then a Langchain example effectively. And what I want to do is take you through, but then I want you to, I'll take you through how I built it or how it was kind of constructed based on the paper. And then I want you to do a bit of a live kind of best practice debug with me, because your graph.ts kind of insight will be a lot higher than mine. But before we get into that, a fair bit of news kicking around this week that caught my eye, which I can take you through. Before I dive in, did you want to mention anything?
Not too much. I think we'll get into the Claude, some of the coding agents items, and then you know me, MCP all day.
MCP all the way.
Anthropic released a new feature, basically like desktop applications. Have you seen this?
Is this in Claude AI? Is that what you're talking about?
It's in
I haven't.
It's specifically for desktop. So it's essentially, they put out a standard where you can convert your MCP servers into desktop applications. And it's just another one of those things where you're like, okay, that's cool. Is it applicable? Where does it come into play? But I think it opens up a lot of avenues. So I've been experimenting with that a little bit. Thought it was worth a mention.
Can you show me? Or is it here? Desktop extensions. One-click MCP server installation for Claude Desktop.
Let me see if I actually created several. Let me see if I can pull these up and I can import it into Claude and show you how that works.
So what's this? Claude Desktop. Yeah.
Yep. So I just went ahead and I created a bunch of these samples. And some of these we've talked about on this podcast. Basically what this is they put out a schema. So you can run a script essentially in the folder of your MCP servers, and then it will convert it into a it's a zip folder really, but for all intents and purposes, it's like an executable, or that's what people might relate to. So again, does this make sense in the enterprise space? Not really, but I think it's a really cool and easy way where like I could build a MCP server. I guess time will tell if this is what this means exactly, but I think it's interesting. So in Claude Desktop, and you made a mention of Claude AI. So this DXT extensions is exclusive to the desktop. And actually, they have a lot of different menus for extensions and add-ons now. I mean, I don't know how much time you spend in Claude, but you have your standard MCP tools, MCP servers. You have things like resources and prompts over here. And then now you have one more area under extensions. So basically what this allows you to do is just, I already prepared these and some of them didn't work. And now I don't remember which ones worked. So we'll try it. We'll go with the time. I think pretty straightforward. So you just drag it in, pretty simple, and depends on how you configure your servers. So if you have servers that require like environment variables and arguments, you can enter those in manually. This is just a time server, so it doesn't have any. I'll do another one there. But you basically just configure it instead of using that JSON file. It's the same information. It's just a little bit more transferable and easy to consume for probably a lot of people. So that's it. I just hit install. Tom, I know you love to see all the errors flying around. This is a development environment. Okay, so back off.
It's okay. Hey, we're all friends here.
So there we go. Just like I just added this time server, and it shows up as it's just like a desktop application. So I don't have too much past that, other than we can share apps really easily.
That's cool.
Well, I haven't heard of many people talk about it yet, so we'll see if it catches on. People have better ideas than I do.
This is like a competitor to say, because, I don't know if you use the OpenAI desktop app very much, but like having it enabled and listening to or connected to a desktop app, particularly when you're doing development work or anything really, is sort of contingent on the ones that they allow. This basically, if you've got an MCP server that will enable that, then you I'm assuming Anthropic, their product approach is basically do things that OpenAI isn't willing to do because they've got so many users, to try and get ahead of them. And this is probably an example of that. Man, that's cool. I have to play around with that.
Those are different errors. So yeah, just like that.
I'll check this. Yeah, I'm looking through the GitHub account now. So they've got like a GitHub explainer for DXT files. Yeah, that's cool. And then you can have prompt templates within there. Like, oh, right, okay. I guess another thing that they're probably considering is like they basically brought MCP into the world, but didn't really get any competitive advantage immediately from it. If you know what I mean? Like, so they're probably feeling like, well, how do we leverage this protocol that's now exploding to accelerate Claude's distribution? Because they really don't have as much. Like they dominate in the dev space, but they just do not compete on the user base at all, really, with OpenAI.
Yeah,
at least for the moment.
Didn't I read they like quadrupled their revenue this year?
Yeah, so but OpenAI has as well. So
yeah,
I believe I'd have to double check these figures. It was something like they're projected to break through 2 billion in revenue, I believe, or if not more. That's Anthropic, but OpenAI did a capital raise, and they basically, in their projections, they put that they expect next financial year to do about at least over 10 billion in revenue, and by 2030 or 2029, they're projecting to do over 100 billion in revenue, which would, put them up there with the Mag. That would mean they would become a Mag 8, right? That'd be a magnificent number 8. So they're just on a different plane, and I think it's as a result of all of the users they have, but they're still losing money, right? So even despite that, they've said that they're still losing money. And so is Anthropic. So they do capital raises, and so it's not like they're profitable yet. But anyway, I digress.
I mean, I don't know how much it weighs in, but I was thinking the other day how, no matter what LLM provider it is, a lot of them use the OpenAI standard. Most
of them have kind of coalesced around the OpenAI compatible API standard. That's for sure.
And like any demos that you do or like example projects, everybody just uses OpenAI.
Yeah.
Because it's like the standard, right? So I wonder how much. I'm not going to even speculate that it's fake revenue and it's just a bunch of people running tests, but I wonder how much that is, because I know for me that's true. Like, I don't typically prefer OpenAI for most things, but I start out with it almost all the time, you know?
Yeah, I'll get into that in a second because there was an interesting report from Iconic Capital around the state of AI where they talk about the distribution of different companies, AI native or AI enabled, and whether they're rolling their own, have their own inference, or just go via the API, which is sort of like inference, just paying someone else for it, right? One thing, speaking about OpenAI, one thing that I thought was interesting this week, if I share my screen, was on OpenRouter, which you may or may not be familiar with. OpenRouter is sort of like a developer-friendly toolkit for switching model providers. It's used by Klein, Rucode, those kind of guys. You see my screen here, yeah?
Yep. I don't even want to tell you how much money I've spent on OpenRouter.
Oh, well, what you should do is as soon as a model like this pops up, because it's free, right? Cypher Alpha is free, and the community of OpenRouter, whoever uses, has put, since it landed there about a week ago, 5.4 billion tokens through this model. The last time this happened on OpenRouter, it was OpenAI testing and evaluating ChatGPT 4.1. So this is almost definitely an OpenAI model. The question is it ChatGPT 5, which Sam Altman mentioned would be dropping by the end of summer, or is it the open weights model that they've been talking about? Either way, it's definitely an OpenAI model.
Million tokens context.
Yeah, million token context window. Maximum output is 10,000 tokens, which is significantly higher than some of their other ones. Yeah, I haven't used it yet, but obviously there's quite a lot coming through. It's in stealth here. You can try it out, but yeah, you see like Rucode and all these apps that are using it. Some of them are just chat apps, obviously. Some of them are just literally evaluation apps. But yeah, that's pretty interesting. So last time that stayed on there for a couple of weeks, and then it was announced, which is pretty cool. So yeah, you should load it up, given the fact that it's free at the moment. Just put everything you can through there.
Oh, we don't have any idea who runs it or where, or it's just like, hey, it's free.
It's free. Well, it's almost certainly OpenAI, because this is exactly what they did with ChatGPT 4.1. They did the exact same thing, same community, same place, same mechanism. It was by stealth. It was free. Yeah. And it had a similar naming system as well.
Did you say you've tried it, or?
I haven't tried it, no. But it was interesting.
One of these silly, like crazy prompts for creating like a 3JS. I have a bunch of these. I'm going to run it, see what happens.
Pull those up. That'd be a waste. Yeah, I thought that was cool. So it means we're getting a new model from them pretty soon, which is a 1 million token context window model.
Which 4.1 also is, right?
I believe so. Yeah, the other interesting thing that I saw this week was this report, State of AI report from Iconic Capital. And it's an interview with a range of different CTOs, CIOs, etc., from different software companies. It's one of those classic, like, let's interview a bunch of people and figure some stuff out. A couple of things that I found interesting from this. You can see like the kind of companies that they interviewed were here. So AI-enabled sort of software companies like Atlassian, AI-enabled where they're creating a new AI product like Intercom with Fin, or Salesforce with like the Agent Force, or then AI-native companies, about another third, where they're just AI products, like their new, like Cursor, for example. One of the more fascinating things I found was, there's a couple of things. One of these is like prompt-based techniques for these high-growth companies, like some of these high-growth companies are just basically that combination of write evals and just prompt engineering, which I found fascinating, like just accelerating revenue just with the prompting side of things. Skip over that one. One that I found super fascinating
Can you
was...
expand on that? What do you mean by just...
It relates to something I saw one of the guys from Y Combinator say, which was like, you can get a long way in the new world of building AI-enabled software by just having a great data set, like a good eval set that's unique to a use case, and then just prompt engineering your way to a great outcome. Like, and I think that's an example of that, where these high growth companies, like, I think there's an assumption if you're trying to get a competitive moat or just like get growth in this space, that you have to roll your own model or, some sort of unique tech approach. Whereas like prompt based techniques are not, that all they are is just optimizing text, right? I think that's pretty interesting. It doesn't take a lot, which is exactly what I want to take you through in that Microsoft example. Like, that's prompt engineering, but they you can outperform, the soda with just like great prompt engineering and a great data set. I don't know. It's quite inspiring to me, really, because it means like you don't necessarily have to have, AI engineers who have previously worked at Meta and are getting like $100 million reportedly signing bonuses, right?
Well,
there's space for a lot of people.
It kind of goes back to the age-old idea of, to get good information out of your data, you have to understand your data. And maybe there's a perception sometimes that, now the LLMs can just do all the work. But
yeah,
we talked about it a little bit last week. Like, you still have to understand the data, and it doesn't take as much as you might think. If you can prompt it properly, if you structure things well. So I'm totally in agreement there.
Yeah. Just because you got a really high quality tool doesn't mean it instantly makes you an expert, right? The other one was this, which is basically the budget allocation distribution of companies pre-launch, when they're in a beta, when they're in general availability, or when they're scaling across these respondents, and where they actually spend their money. So pre-launch makes sense. Like, basically, if you're pre-launch, you don't have as much money, and as you go into beta, generally, GA and then scaling, like, you're going to have way more money. So just because the percentages change doesn't necessarily mean in absolute terms you're spending more or less money on, or less money on a certain amount. But what I did find interesting is down the curve. So when companies get bigger in this AI native space into the scaling domain, the assumption would be that you are spending more money on, say, rolling your own or training your own models, or on inference. But actually, at scale, the cost of data storage and data processing is just as much in terms of percentage terms of their budget as inference. It's actually more than inference, and also more than their model training costs. I found that pretty fascinating for a few reasons, but number one, it sort of bucks my assumption around like where the money's going to coalesce. So I think everyone's talking about how NVIDIA, and these new chip providers are going to capture everything because they're just going to control inference. But actually, there is going to be an explosion of database providers and data storage solutions for these companies. I found that really fascinating. Then there's traditional cloud costs and AI infrastructure. So there's a blend in there, and there's another sort of 22% that they list. But I found that really interesting. And Thomas Tungus talked about this a little bit this week. He's an investor that I follow quite a lot from Theory Ventures. He just invested in a company called LanceDB, which specifically does this. It's like multimodal, high scale, high performance database for AI native apps that bring in different types of data, and you need to query them, or, obviously these apps create a lot of data, but then they also need to store it and reference it effectively. So yeah, well, that was pretty interesting.
Taken off as much, like probably a year ago, I made some investments and or tried to make investments around companies benefiting from like vector storage and memory, RAM, because it takes a lot of RAM. It hasn't taken off quite as much as I thought, but also I feel like RAG and embeddings, not that they've fallen off by any means, but people have found alternative techniques, different approaches.
Yeah. Well, it may be, so a couple of things on that. It may be, say, data storage and processing 13%. Like, I was sort of under the assumption that inference was just going to be like the key thing, right? That's what everyone was saying. But then there's this massive data storage and processing kind of chunk. It may be that a lot of that just concentrates into the key cloud providers anyway. Kind of like, you know, when everyone was going bananas over NoSQL. Do you remember that phase? And then it turned out that it was just more convenient to use Amazon's version of that than Mongo most of the time. So I don't know about the specialization path as much, but I found it interesting that it's not the story that we've been sold, I guess, or that we've been focusing on, because like the whole NVIDIA kind of like chip provider story takes a lot of the focus in terms of like what the infrastructure stack is going to look like. This looks pretty different to what I was expecting. Yeah. That was all I was thinking about there.
Inference goes up, storage. Yeah, I'm going to have to look through this report. Looks like really good data.
And then AI talent just remains at about 30 to 35 to 40% of the total operating expense once you get past the beta, which sort of makes sense. But, you know.
They explain it somewhere here, don't they? Or or do they leave it open for us?
I think they leave it open. Well, I can put this in the show notes for anyone who's interested. The only other thing I was going to say is they go through for their respondents, like 300 or so people, what all of the different apps they use are. So who's dominating kind of the respondent use for all of the AI specific tooling. So model training and fine tuning, LLM AI, you know, application development. There's all of the different, you know, companies that you would expect all the way through here, which is kind of cool to see. One thing that I found right at the bottom is like product and design. They basically said like Figma just dominates, like 87% adoption, even with all of these, you know, leading edge companies. No one is disrupting Figma's kind of mindshare and usage, which is kind of newsworthy because they you know, are listing shortly, and they had their S1 announcement in the last week. And a lot of people have been saying, oh, maybe they're going to be disrupted. You know, are they going to continue their dominance? Everything in that figure tells me that they will continue to dominate the design side of product development for the foreseeable future. That's my call. I'll definitely buy some if I can. I don't know if you saw that this week.
It almost seems like it could be like Microsoft Office type of, you know, like the universal standard.
Yeah, well, that's what we all thought when it was Adobe, but then all of a sudden it wasn't. So obviously these things can change. But it's definitely not going to change in the short term, I don't think. Oh, this one, you're a Cloudflare Cloudflare expert. Did you see this? So Cloudflare introduced effectively a mechanism to ask for payment from LLM crawlers to access content. This is their announcement here. Did you read through this, or did you see this when it came out?
No, I actually is it related to containers?
I don't know. I think that was a separate thing. But I think that was actually a separate product announcement they have. This one was specifically around being able to, if you want, basically to request AI crawlers that if you want to give them access to your content, you can require them to pay or make a microtransaction of some description through their infrastructure to block crawlers or block them from accessing your content, which is pretty cool. Yeah. And it's sort of an interesting evolution of how content is brokered into these LLM engines in real time as opposed to things that they've trained on. Yeah.
When did this article come out?
This came out 1st of July. Yeah. So this week, only just. Yeah. I thought that was interesting. What's the container announcement they did? Is that like a
I don't even know if they really did an announcement about it, to be honest. Like There's a blog post from a few months ago saying that they would release it in June. And then, even on this show, we've talked or demoed the Cloudflare MCP servers they put out, and they had a MCP server for containers. And I was like, that's weird because this isn't even a product. And then just the other day, I work primarily in Cloudflare. I opened it up, and now I have the ability to create containers. So very similar to Azure containers or any type of container offering. But I'm big on the ecosystem, and I think Cloudflare's done an amazing job putting together, and we're continually growing that ecosystem. So, for instance, you can, without having to create a public API and a lot of different complexities, you can just use bindings, and you can give your agents access to a container. I mean, there's so many different things you can do with it, including web scraping, media conversions, stuff like that. So that's why I thought it might be related. And I think it possibly is underlying that article you brought up.
Well, I know they've been doing I think they're underestimated as how influential Cloudflare actually is in terms of the amount of traffic that goes through them across the entire internet. It's something like 20% or some figure like that. So they have massive influence over, I guess, how things are done in that regard. One of the announcements I thought was interesting in the similar vein to this kind of brokering transaction kind of mechanism for AI crawlers was they released a AI kind of House of Mirrors a couple of months back. Did you hear about that?
What?
So it was basically House of Mirrors. Well, that's sort of what I'm calling it. But basically, it was a tool to basically, as soon as it recognized that there was some sort of AI crawler or AI bot coming onto your site, it would spin up an environment of self-referencing content using AI, and then force the bot to continue crawling within self-generating pieces of content that were meaningless within itself to basically run around and just churn through tokens on behalf of the crawler to just basically crawl through a bunch of garbage that was self-referencing.
Yeah,
which I thought was kind of cool.
honeypot.
I don't know if they're still doing it, but I thought it was kind of funny. It was very Superman, stuck in a hall of mirrors sort of shit.
Yeah, I'm looking now because I feel like where I saw that, the article it wasn't from the article. I think I was actually turning these settings on in Cloudflare the other day. So yeah.
But I thought this creator one was kind of cool. But then one of the things that I guess the counter to this is they've already got paywalls and things like that. And someone is going to give this content away for free. So it's kind of hard for publishers to stay away from this. It's probably better for them to have if you're big enough to have a direct brokered agreement with these companies like Perplexity or X or OpenAI. Do you have any thoughts on this before we move on?
Yeah, you can. I believe you can just completely block bots from being able to access your site. Period.
Yeah. I believe they've got that. And Vercel launched something similar at their thing, and hence why they've got under attack. That's probably one of the best CTOs I've ever seen. Are you under attack? Oh, that's good. The only other thing that caught my eye this week was this Epoch AI, large-scale AI models kind of graph. Just these guys publish AI-related data and research, and just the number of large-scale models that are increasingly being released. I think the metric was one large-scale model, the equivalent of GPT-4 every 2 weeks. Every 2 weeks, so 2 a month, is now coming out relative to what we had. Just an explosion of these high-scale, large language models, or large and multimodal models, and you can see them here. Just the number of them that are just released is just increasing, and the scale that they're getting to is so much higher, which really puts the perspective on some of the AI regulation that was being considered into like was so foolish, really, because so many of these things would have had to have been like self-reporting, self-regulating. Like it just doesn't make any sense at all. It's incredible, really. And when you look at the number and the distribution, the types from small to large applications, science, speech, image generation, video specific. Yeah. It's super exciting.
Were you telling me one day that you got into the small models or like the?
Yeah. Yeah. That is still a yet to be launched summer project that I want to do with my kids, but it's this one, Gemma 3N. So it was research only or research preview, and now it's full availability of this model. And it looks incredible when you look through the documentation. It's like a 4 billion parameter model with this nested architecture of 2 billion parameters active, which means it's way more efficient and can be run with, significantly less kind of computational requirements as a result of its architecture. And it's multimodal in that it understands and processes text, audio, images, video. And it has I think it's over 100 to 150 languages. It's incredible. This model is insane.
Yeah, and if you've done anything with the local, the smaller models, that's huge. Like just we're so used to the multimodal and the closed source and the bigger models, but having actually capable models for, whether it's image, audio, it's a huge gain.
I don't know what the adapter is for this but this is the Olama version where you can download it. I haven't started running this locally, so my goal for this was to run this model multimodal on a Orange Pi device. Those there's Raspberry Pi, and then there's the Chinese version, which is the Orange Pi. They're only about $50, and it has the potential to be able to run one of these models. But then I'd need an adapter, which is audio, a text-to-speech adapter. I've got there's a couple of packages out there which should work for that. But this model seems incredible. I'm assuming this is going to be deployed on pretty much every single Android device everywhere in the world, just based on its size. And there is an adapter for Apple devices as well. Everyone else to deploy models onto iPhones. And yet they have their own. I know we've been experimenting with a few of them, and they're garbage. They're specific small models for on-device executions, pretty average.
Yeah, I mean, I'm a big believer in these, local models overall, but especially these smaller, specialized, and I just think they haven't taken off. It hasn't even started yet. I think people start finding hybrid use cases here pretty soon.
Yeah, sorry. The framework I was talking about is this MLX, where you can run open, and there is an adapter for the Gemma 3N model onto Apple devices through this MLX kind of package or framework, I guess. I'm not an expert in this, so it's not my thing, but I thought it was pretty cool. So I think, I don't know, I've got a Pixel 9, and there's a lot of on-device kind of AI stuff kicking off on there. It's pretty good. It's really good, actually.
Like what? What do you notice?
There's
not
this
necessarily to just read about, but where you're one day you're like, oh wow, that's.
Well, there was this feature that was in a prior Pixel that I had, and it's just an Android. It's a Google Android feature, which is really cool, where someone gives you a phone call and then you can just put them into a answering machine, but the answering machine then live transcribes the text onto your phone screen, and then you can load up chat responses that will then be described by the basically the answering service back to the person. And then you get their responses in text on your screen in real time, even though they're discussing it with your AI assistant. I don't know. I put my friends through it when I don't want to talk to them. That's and it's really, really responsive. It's really fast now, whereas before it was kind of average, and that's all on my phone.
Yeah, I've run some local models on my iPhone and actually been pretty impressed. I didn't even think that would. I thought it would barely work, and I'm like, oh yeah, it's actually pretty responsive. It's pretty quick.
Yeah, we're doing a little bit of stuff with those at work, and the main constraint, they are good and you can run them offline, right? The main constraint is they have a really small context window, so it's kind of hard to do anything with like more advanced tool calling, or yeah, they're going to need to sort that out. Like a 4,000 token context window. Now that might just be the one model that we're experimenting with. There might be other ones, whereas these guys, this one's got like, check it out. I think it was 32,000, right?
Mm-hmm. Yeah, that's what I mean by I feel like people just haven't found the use cases. I mean, some people have, but them part of a system rather than try to use them. So you might have a smaller or local model doing like you said, you're very limited on context window. So it's not your workhorse, but it can do some of the upfront work, whether it's categorizations. That's actually a big thing that I've used local models for, is like categorization of things. You know.
All right. Those are all the things that caught my eye. Anything else?
I don't think so, but hey, if you're in the market for Raspberry Pis, just let me know. I got like stack of them that didn't get off the ground. I think I probably already mentioned that. I found myself playing with Raspberry Pis, and I'm like, where are these kids at?
Well, because I spent a while with O3 on this idea, and what sort of came out with these devices, which is Orange Pi. One of the reasons for is this rock chip, kind of AI enabled or inference capable chip that's significantly, here we go, embedded NPU at really, really low cost. I think it was $30 or $40, something like that. So my goal was like to just crunch down the price as low as possible to see, like, could you get one of these like leading edge, that Gemma 3N model running on like a $30 device? Is that even possible? Or what would the constraints be? Whereas like the Raspberry Pi ones are like what, $200 or $100 starting.
Yeah, but I don't remember what model it is. I'm looking here. Like, have you seen the ones that are like this big?
No,
It's like the
I
size
like
of a
mini
key.
ones.
It's like those, and I don't remember what model, but I had it was running on this little tiny $20 device.
Yeah, right. That's sick. And what were you doing with it? What were you doing it for? Or was it just to like give it a try? Just try it out?
Yeah, I did a couple things. Like, well, now that I think about it, the main thing was a home assist voice assistant, but that actually is not purely the LLM. There's other stuff there. So
Yeah. Well, maybe I'll do a demo of this once I get it running. And you could bring your Pi one on, and we can like make them debate. We'll have like a live debate between them.
man.
See who's smarter.
I'll bring my Legos as well. Raspberry Pi 5. No, that's not good. Pico. Raspberry Pico. It says available now from $5.
$5. Yeah, right. Okay.
20.
Give that a try. All right. Do you want me to? I'll clean this up, and then we can jump into the demo. And give me some advice.
Man. I'm excited to see it. What I'm most excited about is now I can cancel my health insurance. Dr. Tom, he's got the agent.
Yeah. I would. I'd hang on to that. I'd hang on to that for a bit until you see the effectiveness of my agent.
Yeah, but if you look at the numbers, and what was it? They were getting like 85% accuracy. So even hey, if you're a medical professional, I'm just joking here, but like the percentages weren't that high to begin with, apparently. So,
all right, for the demo this week, I thought I'd take a paper that was doing the rounds, which was this paper by Microsoft, or the team at Microsoft, who they work on applied medical AI effectively. And they released a paper where they talked about having a mixture of agents applied to medical cases that outperforms not only the leading frontier models, but also when they get actual doctors to basically evaluate the data set it outperformed those doctors as well. And I thought, let's talk through that because I found it quite interesting. And then also let's talk through how could we potentially go about building that in something like LangGraph and Langchain, using Langchain, and then go through the tracing using LangSmith. And then maybe you can give me some coaching in terms of like my graph structure, because there's definitely some things in there that need to be improved. So I thought that could be fun. So did you see this blog post at all?
Yeah, I did find it actually really interesting because I have people close to me in the medical field and talk about some of this on occasion. So
Yeah. Oh, cool. All right. Well, what I might do is I'll briefly give people an overview of what it was. So here's the blog post here. So as I mentioned in the intro, they wanted to understand, could they get an AI agent to outperform your standard medical professionals on specific benchmarks, trying to diagnose certain conditions or certain things. And they used publicly available data, and then they used open models that they could get their hands on that were still commercial. So they used models from the leading model providers, and then they also built a specific app to test this. So what they actually did was they created a series of medical challenges. So they got a bunch of case examples from the New England Journal of Medicine. Have you heard of that before? New England Journal of Medicine? Yeah. So here it is here. It's a leading medical kind of journal. Actually, if you go to the website, they've got data sets and benchmarks. There's like an open set that they actually publish here as well of other things that are not the ones based on this research. So they actually seem to be pretty leaning into this sort of open data set, eval set kind of space, which is really cool. And then there are other medical ones on Hugging Face if you go on Hugging Face and look for other data sets. But the specific data set that's...
I'm sorry, the New England Journal that you're talking about?
Yeah, they actually publish.
Well, did you know that they have an exclusive deal with OpenEvidence now?
I did not know that. So OpenEvidence is the startup, right?
Yeah, they've exploded, and I feel like, I really don't know, but I venture and I'm kind of actively working on something in this area actually, and I feel like it's actually pretty wide open because the OpenEvidence is one of the only, they're crushing everybody, and they have a really cool story. But what's really interesting is that they only became HIPAA compliant like yesterday. I mean, the more I've got into this area, I'm like, I don't think people are even trying, and I can't say that for sure. I know people are, but I know for me initially, it's like that's such a barrier to entry, the medical field. Like unless I knew people, I wouldn't even venture in that area. And I just feel like that's probably how a lot of people are thinking. But I feel like there's a lot of opportunity there.
Yeah, well, if you consider that so much of the consumer level interaction with these AI models is medical or psychology related, it kind of cat's out of the bag, right? Like you can't really, it's like one of those things where you would just say, well, there's like potentially hundreds of millions of these conversations going on every day. You know, you kind of have to lean into it and sort of maybe loosen up some of the constraints, I'd say. But you probably wouldn't want to be one of their backers in that conversation. Would be a bit scary. Be a bit scary. Yeah, these guys are really cool. Yeah, and they've got this New England Journal of Medicine. There is actually a Google model that's available that's similar to this that they have built specifically for medical kind of applications as well. It's like a closed kind of, almost like it has more guardrails on it than their regular models, and it's available through Vertex. So there's a few different sort of API products related to that. Anyway, back to this. What they actually did was they got these New England Journal of Medicine case proceedings. So there's in every sort of episode, I guess you'd say, of their journal, there's a very detailed case description of typically pretty rare conditions. and it goes through in very fine detail, what were the symptoms and what were the tests and a range of other data, and then the eventual diagnosis and how it's based on this description, like basically how they got to that assessment. So it's an incredibly rich data set for an eval like this that you would need to test an agent, right? But it had to be transformed. So these guys, they built this specific data set called SB, I believe SB Bench, which hasn't been published. SD Bench, pardon me, sequential diagnostic benchmark of 304, a subset of these cases, 304 of them. And they used that to basically try and figure out if they could create an agent that would then iteratively kind of find its way towards a diagnosis, which is pretty cool. So that was step one. And what they needed to do was figure out, all right, what's the architecture of the agent? What's the agent architecture? What are the actions the agent can take? And then how will that agent be fed information about the case in order to develop its hypothesis around the diagnosis and then eventually make a diagnosis? So that architecture is outlined here on this diagram, which you can see that I'm sharing. Can you see that all right there, Cameron?
Yep.
So basically, the core model that they used was O3. And then they had a set of O3 models that are prompted with a specific persona. So that a challenger doctor, challenger agent, they had like a checklist agent, they had a stewardship agent that was, kind of overseeing everything. They had an agent that was generating hypothesis, and then they had an agent that would test, that would choose which diagnostic tests should be ordered. And then that was basically this chain of debate function where they all basically contribute just to one state. And then at the end of that round of evaluation, a decision was made from this sort of orchestrating agent, which was like, you need to ask the patient a question, follow-up questions based on the information they have. You could request a test, or you could make it provide a diagnosis. And then there's this other kind of agent that feeds information back to this kind of chain of debate, kind of swarm of agents that knows about the case that they're trying to diagnose and can provide them information. And basically what they do is that agent will basically say, all right, well, you've ordered this blood test, blah, blah, blah. Here are the results. Now, those results could either be the real results that were from the actual case, or synthesized data of, say, if it wasn't related to the case. The reason why they did that is they found actually if they just provided like, oh, no data found, actually there was a reward hacking function that emerged where the LLM swarm, if you can call them, of doctors realized that, oh, I must not be onto the right track because no data was provided. So they actually had to kind of create this false data set, which I found pretty interesting. Did you read that when you were going through it? Yeah. Like reward hacking comes up everywhere. But essentially that kind of data information or kind of gatekeeper agent feeds back the information that from, say, the requested test or anything like that, or like a question that they might want to ask the patient, and then it synthesizes kind of the response, which I found interesting. Over the top of that, they also had this cost analysis kind of function. Did you read much about that cost component? Yeah. So what's interesting about the cost component, and I was a bit confused when I saw this kind of diagram here, which I'm showing you, which is sort of a bit too large, but I'll zoom out. When I first saw this, I was like, oh, is there like a computational costs part of this study? But actually it's not. So what I'm looking at here is on the bottom axis, there's basically cost. And on the top axis, there's diagnostic accuracy. So they actually had this like other data set, which was a standardized pricing kind of sheet of all of the average cost of ordering specific types of medical tests in the American medical system, plus a standard $300 fee every time there was a patient consult, which was basically the LLM asking the patient questions. The reason why they did that is they wanted to not only get a diagnostic accuracy of this kind of swarm of agents, but they also wanted to understand, relative to standard medical practice with physicians, what's the actual aggregate cost that was incurred by this agent, which is down the bottom here in thousands of dollars. Because obviously every test has a cost. You didn't want an agent just running off and going, well, I'm going to order 50,000 tests just to figure it out. They wanted to overlay some sort of kind of cost constraint, which was a pretty interesting part of the study. Overall, the results are pretty incredible. So you can see basically standard models in terms of when they were trying to use those standard kind of open models to try and get to a diagnostic accuracy percentage. O3 was like the closest to this ensemble that they built, which was basically just prompt engineering. But it was very, very expensive. So O3 just basically costs $8,000 of tests, like theoretical tests, to get to almost 80% accuracy. Whereas this mixed, they're calling it MAI-DXO kind of blend of agents, could get to 80% accuracy with about $2,500 of test costs, which is pretty amazing. And even just with questions only, so not ordering any tests, it was still significantly more, had significantly higher diagnostic accuracy than, other models that are frontier models when they even got to order tests. So it could get the results or get an accurate diagnosis at 50% of the time just by asking questions, which was significantly cheaper. So it's pretty incredible, really, all from an ensemble of prompts. So just prompt engineering. Yeah, I found it amazing, actually. And then probably why it was causing a bit of a stir online.
Yeah, I was curious what made you become interested in this?
Well, number one, I was like, right, well, that's pretty interesting research. Number two, I loved it because it was just all based on publicly available data and pretty much just stuff that we can build now. So the database for the test cost was open. The question set is actually open from that journal. They just transformed it. And we can just use these models, right? Like they weren't using anything that was custom. It was just O3, what we all have available. So that was what made me interested. The other factor is like, all right, well, how would you replicate this rather than just like this is a theoretical kind of idea. This isn't a product that's available at the moment. We're like, well, how would you build this? How would you turn this into a product? That's actually why I was interested. Like, how could I use LangGraph and Langchain to see if I could build like an interactive version of this that you could then basically turn to other medical requests, either theoretical way where it just asks you questions, or could you connect it up in the future to like a on-demand kind of pathology service to get, I guess, on-demand medical care for people that was high performance and low cost. Like that's probably the most interesting thing of this is like there was a cost attributed to these agents interacting with a patient of $300, right? But in reality, it's like cents to interact with O3, right? And O3 is always available. My physician is not always available. Like I'd have to make an appointment. All of those things are constraints on people getting medical care. And so behind the scenes, if this could be transformed into a reliable, medical kind of co-pilot, it's pretty amazing what it could achieve really for human health based on this.
Yeah. And I guess in the case study, they were talking about like 300 cases.
300 cases,
so
yeah.
I don't know how many this represents, but man, like if it doesn't take a genius to realize the impact. I mean, that's insane. Like if you scale this over like millions and millions of people, that's so significant.
Yeah. And if you consider how many people there are in the world that don't have access to medical care, right? Where cents on the dollar, like, or even just being able to get advice is critical. Like I think we both come from very wealthy countries. The idea that you couldn't get access to a physician is sort of, there are constraints, but it's not something that is a reality for you and I, whereas that is a reality for billions of people around the world, right? And this basically means if you could make this into a product, it means like if you got electricity, you've got access to a doctor. That's pretty amazing.
Yeah, no, you're absolutely right. And like we feel the impact or like we know the impact or we can speak the impact, but to actually feel that, I mean.
Yeah. So there are a couple of things to call out in terms of like the limitations. So this is the actual paper. So they've submitted, this is a pre-paper. They've submitted this to a, I believe they've submitted it to a journal. And I used this when I was reading through this a lot of the time. And this is where a lot of the architecture comes from. So to get an understanding of how they actually built the architecture of the agents and the swarm and this gatekeeper agent kind of concept. And this is pretty interesting actually. So if you were interested in going through it, you can just read through all of these. I'll put it in the show notes. And then there's more detail on the sequence of how they go between the gatekeeper agent and the diagnostic agent. And then, how they basically try and adjudicate onto whether the final diagnosis was correct, all of those sorts of things, and how they built like a confidence score. Apparently a lot of, and I didn't really understand this too much, but a lot of medical kind of diagnosis is based on this concept of Bayesian probability, where it's just a fancy way of saying you've got the universe of potential kind of reasons why this person may have this condition or these symptoms. And then all you're really trying to do is just knock out knock the least probable variance out until you can make an assessment over a certain confidence threshold. So doing some tests, talking to the person, whatever it is. So that's the mechanism, and it's talked through in detail in here. And then they talk through in detail around the estimating the costs. All of that detail is here. A couple of things to call out. The data set is very rare conditions, right? So it's not a great analogy to, what it is to be a real physician, because people wander into a real doctor's office and say, hey, I've got a sore throat and a mild headache. And then a lot of the time it's just like, mate, you're just a little bit stressed at work and you're a bit run down. You'll be fine. That sort of variation isn't captured in here. It's like, this is really, really serious. All of them were really serious things.
Like the most difficult diagnosis, right?
So like, it's not a really great like-to-like comparison, right? So that's number one. Number two, it doesn't consider like the cognitive impact potentially on a patient, and these ideas around like, misdiagnosis or like potential misdiagnosis. If you misdiagnose someone, how that psychologically can affect them if you put them through a process of like, we're going to do all these tests and we're going to like really go hard for it when actually it might not be something serious. That wasn't really considered in the consideration of the actual physician agent as well, which is something that real physicians would do. All of that being said, the thing that I didn't mention before is that they benchmarked the performance of this agent, this MAIDXO agent, which got across those cases 80% success rate with a $2,500 kind of benchmark test cost. And they tested that against physicians that they recruited to actually go through the cases and try and make an assessment. And those physicians got, on average, 20% result.
That's what I was saying, Tom, is that you with an LL or with this agent, maybe it's not so in the red. I mean, after reading that, I was like, what?
But the couple of things to call out, like, so those physicians, they wanted to get a raw comparison against like just what's in a physician's head. So they did it on purpose, though. They didn't give them access to Google. They didn't give them access to a network of other kind of medical people that they would speak to. So those factors are not real as either, like real comparisons. Whereas a doctor in real life would they would talk to their, if they're junior, more to their supervisor, they would go and consult with their colleagues. They would go and find a specialist, all of those things. Plus they would be enabled probably with these Copilot tools already, which a lot of them already are. So that 20%, it probably shouldn't be like, oh, it's 20%, but it may actually be like, maybe it's 50% or maybe it's 60%. But even at those levels, this agent swarm is, well, I wouldn't call it a swarm, this agent solution is pretty impressive. Cool. Did you have any other questions on the study before I get into the demo?
Are you going to cover anything about the evaluations? Because I expected to see like an entire paragraph, and unless I'm skipping past, I barely see anything about evaluations. I thought that was interesting.
The eval set, like, when you say evaluations, what do you mean? I guess
Well,
SD
they're running
benchmarks.
these tests, right? And so, well, I guess they have the answers, right? So maybe.
Yeah, I guess like the eval in this, because the methodology in this is like an academic paper, so it's not a product, right? The eval in this context is the SD bench data set.
Oh, duh.
Comparing
Yeah.
between the physician and the agent. Whereas probably what you would want in an eval set for a product like this would be very different, right? So I guess the methodology is an eval set against this, using the eval set against two solution approaches, as opposed to like the other way around. Just like I have my eval set that I'm benchmarking against like live examples or optimizations within the product.
Yeah.
Cool. So what I did from there is I took this blog post and I took this paper, and then I said, what would it take to create a version of this in LangSmith specifically? So LangSmith, LangGraph, which we have talked about before.
LangSmith.com.
Yeah.
You get to LangGraph, you're LangSmith.
Yeah. So LangGraph being the agent design engine from Langchain, which you can connect up to LangSmith to observe, which I'll show you in a moment. And I was inspired by your demo last episode to give this a crack. So I partnered up with Claude Code to do this. And I think probably the best thing I did, or that I should show you, is I started with Claude Code in a new, so if I get out of there and make this a bit larger so you can see, does that look okay?
Yeah, much better. Thank you.
So I've got my LangGraph, blah here. I'm going to dir Claude example. So, and then I basically just went to Claude, spun up a new version of Claude, and all I did was I said, I want to replicate, this is as simple as it was, this study agent structure using LangGraph, Langchain, make it usable as a chat. And because I'm all about the TypeScript, I use JS TypeScript. I don't know. Do you use Python or do you use TypeScript?
Well, you can't run Python on Cloudflare. So, well, now you can with containers. Now you can, but yeah, JavaScript primarily.
So, all right. Here is the paper and blog post. So there was a few other things that I like. It wasn't exactly this simple, but it was pretty close to this. And then I just kicked it off, right? So we might come back to that, but you can see it sort of, goes and fetches a bunch of stuff, and I might just put it into auto accept. Have you seen it? There's planning mode as well. Do you use planning mode much?
I haven't initiated it. It just kind of does it on its own. I haven't even seen that as an option. Is it?
Yeah, if you press Shift Tab, you can cycle through. So basically, it's kind of like in Cursor where you've got like ask versus agent mode. I don't know if you've seen that, but like this is basically like, it's basically a way of saying to Claude, don't change anything, just research, or you can go and research. This is in the CLI, obviously.
Now, did you add, do you have MCP tools?
I don't. Oh, no, I've got Playwright, I think, or Puppeteer maybe, but that's it.
So it has like internet, basically.
Yeah. So cool. And then it, picks up that it's going to create agent interfaces based classes for 5 specialist roles, implement the chain of debate, orchestration logic. Yeah, so it's pretty good. So yeah, I was kicking this off. It was a bit of back and forth. When I actually was building the version I'll show you next, I got it to stay in planning mode and then update its Claude MD file with the entire plan and then go for it. So I can leave that going while I skip over here if you want, but it's probably going to be require me to come back and just do all this stuff. So I can probably just exit out of that anyway. So I'll just interrupt it. Here
Claude
is
Code
the...
is not supported on Windows, apparently.
What? I did not know that.
Yeah, when I use my Windows computer, like while we do this podcast, so I was trying to install it. It says it's not supported. That's
Claude Code. That's strange. I think yeah, okay, it's interesting. So here is the very, very long Claude Code kind of message interaction. But what I want to take you through and show you is this is the actual app that I built, and it's on top of, me and Claude built it. It's on top of the LangGraph starter kit. So you can go to GitHub and just fork that and basically adapt this. So you can see it still has the React agent built inside of it. But what I was very impressed by is how well Claude can actually interact with LangGraph, and Langchain. Like I was surprised. Didn't take too many kind of re-edits or changes to the actual code to get it to work. That was number one. And that's not what I expected. I thought it wouldn't be as well kind of known to Claude. It's number one. I don't know if you've built anything like that.
About tools, because I mean, that is impressive. If you're essentially doing it like out of the box.
Oh, it has web search, so it can traverse the documentation, and then I pointed it towards the deep wiki recommendation. The deep wiki documentation.
Well, yeah, that makes sense.
Yeah. But even still, like I was pretty impressed. So basically what it did is it created an initial case assessment process in the diagnostic flow based on that documentation. So taking the medical cases input, and it created kind of test cases as well. Then it created these 5 specialized physician agents to debate on the case. I had to get interrupts added in there to make that work. And then basically from an interaction with the patient, it generates dynamically 3 to 5 specific follow-up questions based on the diagnostic gaps that it identifies between what the patient said, so in this case me, versus its the probability standard it's assessed based on how confident it is around its existing diagnoses. Remember, this is all from like 1 or 2 shot Claude coding. Most of it is just prompt engineering. It's incredible, really. Yeah, basic chat interaction. I would like to put some voice over the top of this, but it's currently just in chat. Once it gets that, it takes that information back, puts it back into this chain of debate medical kind of cycle, and then it returns through that process. Couple of things I had to change. I basically had to go in. You can see here, and these are the physician team kind of structures that it put together. Doctor hypothesis, doctor test chooser. It did build out the test chooser functionality, but that's not hooked up to a database yet. So that's in the plan that Claude developed in the MD file. Then there's this challenger, which identifies the existing biases. Then there's the cost controller agent. And then the quality control kind of oversee of the entire process, kind of some sort of, have we covered everything? Are we doing the right things, etc. Yeah. Then a couple of things I had to kind of tweak in the process were making sure that when its confidence level on the diagnosis was above or beneath a certain threshold, make sure it went back and did more turns with the interaction with the patient, and then forcing it to do at least 3 turns of engagement with the patient. So it was basically just talking to me once and then saying, you've got angina, whatever, you're having a heart attack. So it was actually not kind of discovering enough about me and about what was going on. Everything else was out of the box. And then these standard example generated questions, which is basically just few shot examples on the prompts for what we were just basically the medical case. Everything else is standard. So I did push this to GitHub, which we can share, and you guys can play with it if you want. Here, this medical diagnostic agent, that isn't updated, but it has all of the kind of flow. You can play around with it, play with the different settings. Cool. Do you have any other questions on the architecture before I jump into the design?
So everything you've covered so far, it did without any additional intervention, just from the initial prompt. I mean, you mentioned a couple little things there, but
probably 4 or 5 things, plus a couple of catastrophic errors that were introduced that I had to debug. So it was probably maybe like 10, but a lot of the architecture was one shot. So this stuff I didn't change at all. Like, you know, how it turned, like the turnaround on, like, you know, how it interacts with the user. The initial interrupt triggers, I just changed those once I was testing it. And I did that manually in the code because it generated like a configurator automatically. And then these I didn't change at all. So the methods that it took from reading the paper and implementing the prompt structure into the physicians, I didn't change that at all. And these, like probably 70% of this stuff, was initial build.
Yeah, that's amazing, isn't it? I mean,
it is amazing. It's absolutely amazing. The other thing, I started adding extra features. So I've got a couple of feature branches running on this. I added like a Bayesian engine probability modeling kind of thing on top, which I didn't actually add that. It was actually outlined by Claude in the Claude MD file. So my approach with Claude is I basically say, start in planning mode, build out your plan in the MD file, then come to me, which is a pretty standard pattern, right? And then I can start approving the sections. And then as you move through the sections, we create a new feature branch, and then we merge that back into master. Where is the? It's not updated. It's in the README.
Did you put this on? The GitHub? The build GitHub.
Do we have a build GitHub?
Yep. Yeah, you're an owner.
Am I? Oh.
Well, yeah, I know we've set up like every system there is. Here, let me put it in I'll put it in Teams for you.
That would be sick.
I've been putting any of the demos that I've done. I don't know if it's all of them, but I've been trying to upload things there. So it's at least if it's relevant to what we're talking about.
Yeah, I will. I've got it just on there. I'll push it after this. All right. So a couple of other things to highlight. There is effectively what it built was this chain of debate. Let's hide this panel. There's basically like this chain of debate structure where if you look at the original paper, what it basically did was try to replicate this cycle here, how these agents interact with each other. And all it did was basically just put it into one state, right? You could probably give me a sense of like actually how this varies compared to, say, a node that's its own sort of agent that passes back. Basically, this is all within one LangGraph node, and it's all held within this like medical state kind of concept where they just pass it back, effectively like fight it out, and then decide what to do next within this chain of debate kind of class here. And if you look at that down the bottom here, orchestrate. So there's this orchestrate debate between all of these agents. Well, they're not agents, they're just LLMs with a specific kind of prompt on top. And then they go through a certain number of rounds. So medical diagnostic round, executed debate round. And then I could configure how many rounds it goes through on every time. And I haven't actually looked at this, but it'd be interesting to see how these guys are structured. You can see all the different like execution modes here, where they actually have, I believe it's...
Didn't you have it in LangGraph Studio?
I want to pull that up, but I just want to look at the code a little bit more, because I realize when we do these demos, we don't talk through the code enough, and I'm just like, all right.
That's a good point. Yeah, I should.
Always, let's just like jumping through to the main game, which is LangGraph Studio. But yeah, here it is. So here are the roles. It chooses the different physician roles, and literally it's just a customization of their system prompt. And it generated all of this system prompt on the fly based on the medical paper that I fed in. One of the reasons why I thought this was interesting is, obviously, number one, like this was pretty fast and it's actually pretty good. So when I go through a demo, you'll see. But number two, like how many other how many other things are there like this where we could just generate like a mixture of, I don't want to call it mixture of experts, but I don't really have another word for it, because mixture of expert kind of prompt architectures around a problem set that we could develop very quickly. So kind of like using, what I want to do after this is use the assistance feature. Did you see that from the Langchain guys, where you can basically take an architecture and just change the prompts? So it could take this from a general physician kind of application to a, I don't know, a skincare doctor, where it's like dermatology specific things, or a psychology specific thing, just by updating these on the fly.
Like an abstraction?
Kind of like, yeah, you've got the architecture and the architecture works, and then you just update the specialist prompts to apply it to a different subject domain, and you can actually create assistant versions in LangGraph Claude to do that now, where you're just like basically updating the system prompts, but everything else remains the same.
Yeah, exactly. Like your tool sets, what tools are available.
Yeah.
RAG, the assistance stuff is actually really cool.
Yeah. So you can see, yeah, that's the cost doctor and his basic cost considerations. Claude put a default cost cap of $1,000 just by default, which was incorrect, but I didn't change it because this cost chunk isn't implemented. And then this is the checklist one. So primary responsibilities, verify the completeness of the diagnostic workup, all of that sort of stuff. It's actually, yeah, it's really cool. It's really cool. So
where's the insurance agent? That one would be easy. It's like that'd be an easy one. You need like,
yeah. Denied. All right. So what it actually looks like in practice is here. Now, there were a couple of things to highlight when I actually did load it up. So this is, I've been doing a couple of rounds in here. This is in the LangGraph Studio. There's this start mechanism and initialization, and actually the graph has many references back to the initialization, which sort of doesn't make any sense. So that was one of the updates I had to do, because basically it was initializing the case, it would debate it out, I'd get an interaction, it would come back, and then it would overwrite everything by default and get stuck in a loop. And so there was no kind of new information.
You had to add the interrupt.
I had to add in the interrupt, but then I also had to get the solution was actually to add in like ignore if the case is, the same, and have a case ID. Whereas actually what I really wanted in the architecture was just like that initialized case is never there, and it just always goes into the medical debate. But that is actually pretty helpful if you've got like user interactions, I assume, where maybe someone's coming back or they're working on a different case, like sort of makes sense. But it also makes it super messy when you look at it in this graph diagram. But here is the medical debate kind of engine, where you can see it has access to the diagnostic tools and patient interaction, and then the target is patient interaction, diagnostic tools, and then the final assessment. When it goes through its final assessment, it can then, the graph ends effectively. So what I might do is I'll start a new instance of this. So these are all my different threads, a new thread over here. And then if I let's check out all these different inputs. So these are all the different inputs that it's got available to it: available case info, diagnostic tests, the cumulative costs, all of these different kind of variables or input components that come out of it. And then in the initial message, there is actually a example case in here that was generated in the tests. Medical agent test. There we go. So that's like a test case that Claude also generated on the fly to do the testing, which was also really cool. And chuck that in here. Oops. And then we kick it off. All right, so that initializes the case. I'm a 55-year-old male, presents with chest pain, shortness of breath. For 2 hours, pain is crushing, radiates from the left arm. This all sounds very, very serious. And then you can see the medical debate kicks off here. I'll just zoom in so we can just focus in a bit on this, and you can see where it's going. And change it to maybe the preview. You are right, it's quite hard to get a sense of what's going on here. So then it starts with initial consideration. So this is a bit of a constraint on the current architecture, I probably should change it to basically just say, all right, we'll just ask the person more questions up front, but I kind of wanted to see what it would do. And you can see it kicks off its primary and secondary considerations. And then you can see from there all of the different chain of debate functions kicking off. So here is the biases kind of agent, if you will, or sub-agent as part of the medical debate. And it's kind of looking for contradictory evidence, these sorts of things. And this was, it was these elements that just prompting that it looks like gave them that boost of performance, which is incredible to consider, really. And it makes me think
whatsoever.
Sorry.
So there are no tools involved whatsoever. It's pure LLM prompting, right?
At that point, yeah. And also, if you remember when I was showing this part here, it gets to really high performance just by asking the user questions, like without any kind of ordering of diagnostic tests or whatever. It's literally just, there's something about the reasoning potential of having these comparative kind of divergent perspectives. So now it's gotten to here. You see the medical debate. It's not ready for a diagnosis. Its reasoning kind of quality has benchmarked itself as like out of 1 is 0.38. And it's up to debate round number 2. So, and its confidence level on its diagnosis is currently 0, but it has a 0, cumulative cost of 0. And then you can actually dive into each of these components and see where it actually got to and what it actually, like the decision set effectively that it got to across all of those different things. Then it's come back to me for a bit of patient interaction and it's waiting for my input. The interaction round is number 1. I've benchmarked it to say it has to get to 3 rounds just because I wanted to force it to do that. And then it has these pending questions. So it has generated default questions. So here's one: do you smoke, or have you ever described, or can you describe your alcohol use and also your occupation, et cetera, et cetera. These all came out of that chain of debate reasoning kind of turn between them. And it was generated off that few shot example prompt that I showed you before, right? So if I go over to the chat and say, all right, here we go. 1, yes, a lot, and I work in a coal mine.
Black lung.
2, I tried to confuse it when I was testing it. I had an example case where it was a woman. It was a man, and then I just said I'm a 55-year-old man, and I think I'm pregnant. And just watching it go through the reasoning, like, and trying to overcome the conflicting information, and then the confidence like level just going like, well, we don't know what's going on, and then coming back, and actually it was very good. It was like, well, obviously it came back with like a psychosis or a psychological problem.
Did it really?
Yeah, that's what it showed in the reasoning chain. Obviously, that wasn't presented to me in the chat, which I thought was pretty impressive. 2 hours. And it is very, very bad. 9 out of 10. 3. All right. Yeah. No. Yes. Yes. I have high blood pressure. 4. What is it? Yes. They all do. And we'll see what this does with the confidence level. I take statins for blood pressure. I'll see. Now, I had a couple of problems with this before. Maybe it'll be something you can help me with. Push that back in there, and then I should get an interrupt. In this instance, Cameron, I just write resume, right? Correct? Or
or true.
Or true.
You can put true, I think.
True. Now we'll see. I had to debug that for a while, and it wasn't really working.
Do it without the quotes.
Without the quotes. Okay, let's see what happens. I think it is kicking off, but then it's just really slow. While that's happening, I might just go over to LangSmith and see. We can have a look at it in LangSmith as well. Because you're right, it is a lot nicer to look at it through here. And this is the tracing of user responses. It's not ready for diagnosis. It's also incredibly slow when you use O3 for this sort of stuff. I found that it's just like sits here for a while and then eventually will just kick off again if I go into my monitoring, it's in here. You can see the amount of time.
Yeah, building agents. I run into that actually all the time. Earlier today that happened where I'm like kicking the thing, like hitting refresh.
Yeah.
And then all of a sudden it's off to the side. I'm not even paying attention and it just pops up. I'm like, oh.
It just kicks off. Yeah, this one does the same. So you can see there, like latency is like average latency is 153 seconds. So it's really, really slow. I'm using O3 for every single call. Whereas optimizing this would be, for the engagement or the interaction or passing the data, it would be like Flash or, GPT 4.1 or something like that. This should be, it's working here now. All right, cool. So you can see it's like chain of debates kicked off again. So from here, the hypothesis has come back with everything that I've talked about and my response. Okay, great. And then if I jump back into LangGraph, here we go. Medical debate. Yeah, here we go. The debate continues and it's already come back to the patient for the follow-up. So number of agent turns, where is it? The challenger, recommendations, biases identified, reasoning. Here's the reasoning here. And then it's obviously requesting. So you can see here, it's like they're requesting, all right, has an ECG been performed? All of these sorts of things. Remember, like none of that was programmed in. All of that is just default O3 behavior, right? That's the other thing that I find incredible about this. Now, we're not doctors. Like I'm not evaluating this as to the accuracy, but this is exactly how this study would have been structured and how they did it, right? And this is the result. And then they compared it against the performance of actual doctors. So it's kind of inspiring because it enables developers to step into spaces that in the past have been very challenging for them to step into, provided that you've got the ability to benchmark against high quality data sets and, have oversight from professional experts. Whereas it would have been very challenging for you to do something like this in the past.
I would be interested, like you just had OpenEvidence, and I'm not trying to make this a OpenEvidence commercial, but I would be curious how they compare because they have been training models on like PubMed and for like the last year, I believe, New England Journal recently. So
right, yeah. I would be interested to see how. I would be interested to see how it compares with a fine-tuned model. What I find fascinating is that is fine-tuning better than just great reasoning? And this method that they show, which is basically a version of, now this model that I've built is not exactly the same, but it's a version of, which is the chain of debate, right? Effectively, it's all kind of happening within here. Chain of debate, improved context, more data, et cetera, and they define this kind of like structure around the 5 as the best way or the way that they wanted to do it. That surely must go on to be or will go on to be features of reasoning models that are being developed in the background, right? If you imagine like this performance boost here around diagnostic accuracy, if it's as simple as just architecting the internal reasoning chain for these models as assuming personas around a certain use case, that must be something that is in development around how these models are being developed to improve their performance around reasoning, which means, if that is true, would it be better just to improve the reasoning chains as opposed to building custom models? Because we've already got like the Rolls Royce of like reasoning over here with O3, as opposed to going down the rabbit hole of customizing and fine tuning, a custom agent. I don't know the answer, but that looks pretty promising to me. If this plays out across other domains. What's going on with my chat? All right, I might just jump back into the chat and then I can call it a day on the demo. Unless you got any specific questions, you want me to jump back into? Where's my chat? Here's my chat. Cool. Or maybe I haven't done this round yet. True. Here we go. You're saying just true. Resume. Okay, cool. Yeah, so there's the next round of questions, and on it goes. Yeah, that's it, man. It was a lot of fun. I'll update that on the GitHub and share it, and you can play around with it.
Yeah, dude, it's super impressive. Like the fact that you're talking about like thousands of years of knowledge and it has to be so precise. It's so difficult of a problem. And you, like, not a medical professional, as far as I know, you're about to be mine though. And that you basically can replicate like a team of people with, you just paste it in some couple things, have a general understanding, and it's like incredible.
It is incredible. It is incredible. Now, a couple of things. Obviously, that hasn't been battle tested, but it wouldn't take a long time to battle test that. But it's enabled by the fact that, say, I can plug it into, in this case, you and I are more familiar with, and we work with Langchain and LangGraph. I can plug it into an engine that is an agentic kind of architecture framework relatively easily with AI developer tools, and then observe it and iterate on it pretty quickly, which isn't something that they talked about in their methodology. So I don't know if they rolled their own, or because they're with Microsoft, they used Microsoft's, framework, whatever it was. But I think that is enabling. And what makes me excited about it is, like, you could go to so many of these studies, right? Ones that don't even involve AI. You could go to a study that was like this in social science where they used, available data sets and go, all right, just plug it into Claude Code, play with it for 2 hours and see if you've got a workable kind of agentic solution that can significantly outperform like a standard experience someone might have with a service or a product. Like, that's really cool. Like, that's really exciting, particularly given that all of that data was available for free. It's all available there. You can download Langchain and, the open source packages, and you can use Claude Code or OpenAI. It's relatively cheap. Like, it's unbelievable. This age is incredible based on that experience. Like, that was like an hour and a half of work or something like that. Like, it's unreal.
I agree. I don't think a lot of people understand. I mean, a lot of people do, of course, I'm generalizing, but like the amount of overhead costs that have just been eliminated. Absolutely nuts. Like, so a lot of the things I'm doing in the cloud would have costed like hundreds of thousands. I mean, so much money, and it's like nickels.
Or even if, because I've built a couple of enterprise software apps and businesses in the past. If someone had have come to me and said, all right, Tom, you're a product manager, and this is the app that we're going to build, like that medical assistant in 2017, I would have said, give me $10 million and I might come back with something that might work. I have no idea. Like, I legitimately would have said that. And now look where we are. Like, that's amazing. Like, it's an amazing time to be alive if you love software. That's all I have to say.
Right.
Yeah. All right, man. That's all I've got this week, but that was fun. Hopefully you enjoyed it. I'll share the code. Maybe you can improve it and get rid of that.
Yeah, that's
Prove
awesome.
the graph
and
for
actually,
me. I need you to prove the graph. That graph is really ugly and I need it to look beautiful.
Yeah, we got to figure out a couple things, but we have a hosted instance of quite a few things, actually, like Open Agent Platform. I was going to say, oh no, it has to be the same key. I don't know. We should try it. I was going to say, you could send me that graph ID and I can add it into OAP.
Yeah. I've just got to merge this thing, this Bayesian engine, the probability thing that it added. I've got to merge that. Once I do that, I'll update it. I'll send it to you. Yeah, it's sick. Look at me. I feel like a developer. This is great.
You are. You've been lying this whole time.
It's all a ruse. I just memorize keywords.
If
all right, mate, this is a lot of fun. I'm going to go. But yeah, great episode of The Build. That was a lot of fun. See you next week.
Yeah, man. I'm impressed. And I was unexpected, and that's always good. So like, I did when you sent that to me, I was like, is this the right chat?
That wasn't a complete shit show. No, I'm really impressed.
No, that was really, really good, man. Really good.
Oh, that was fun. That was good. All right, mate.